Yeah, hi. Today we're going to talk about trench shields, or as they're called in the industry, drag boxes, and how they're used. There's some, with trench boxes, or trench shields and drag boxes, it's a minimum investment, it's a fast production system, it's really a simple concept, and it's safe if it's done right. The issues connected to a drag box is the length required, which is driven by the pipe length. Typically, the box should be, to be safe, needs to be 4 foot longer than the pipe to give you a little room in the front to check your pipe grade with the laser target, and in the back, usually the soil slopes in and you have to be protected while you dope the pipe up ready to put it home. The diameter of the pipe drives the width you usually use on a trench box, and the capacity of the trench box is being driven by what type of soil it is and the depth of the ditch. And then now you have a trench box that weighs a certain weight because it has a certain length and it has a certain width. So you need a box that also, when you choose your excavator, that the excavator can lift. Now I want to get into a little bit how the trench boxes is used, or drag box is used. Typically you dig a trench. The length of the box is required to be, let's say if we're laying 14-foot length of pipe, to be safe, 4 foot longer, you would need an 18-foot long box. So you dig out your trench, you wouldn't be laying your pipe yet, and you just set your box down in. Then you'd put your gravel and go ahead and lay your pipe. That's typically the way it's done. Then at that point, you would dig out that 14 foot in front again, and just literally just drag the box ahead, and do that over and over and over again. It's really a simple concept, it's really fast production, and a contractor can make good money doing it that way. But now if the soil's unstable, and you can't get the ditch dug out sufficient to pull the box ahead in a complete dragging motion, there's another method connected to it that's called drag and drive. So typically at that point, you would slope your trench in front at an angle, because you can't get dig down because it just cave in on you. You lift the front of the box up, you drag the box ahead at that angle, and then you dig inside the box as you drive it down. That's where it becomes important to be able to rack a box. We can go over here to a little bit of a sample of a box to show how a box can rack. So you drive one side down, drive another side down as you dig inside of it. You can probably see better, that's the back, you can probably see it, just get it better from the front. That's as you drive it down. And now when you're pulling a box ahead, also what you need to be doing, you kind of need the back of the box to be narrower than the front of the box. So we and all the other manufacturers, we oversize the pinholes, so as the pressure comes against it, it pinches the bottom back. So when you're pulling the box ahead, you're always uncorking. Now when you're dragging a box ahead, one of the issues you also get into is the pressure will come against the box typically, and sometimes you have to break it loose. So you need a little racking also as you pull the box ahead. So the next issue we should be concerned about is deflection of the box. A trench box is what I consider similar to, is built similar to a beam. The outside and inside skin would be like the flanges of the beam. Then the distance between the flanges would be like the thickness of the wall of the trench box. So an example, the narrower the height, the less the height of the beam, the more apt you can pitch it in your head, it's apt to deflect as you bring pressure on it. Now you got to remember, I think we all agree that steel is still like a rubber band. Maybe it doesn't stretch as far as a rubber band, but steel will stretch and it'll come back, is what it does. So as you have a narrow beam or a short height beam, you push on it, it'll like spring up and down. You know, you drove across the large bridges and how they spring you can feel the steel springing, especially when a big truck goes over. So the further apart the flanges are, the less apt you're to have deflection. Now if you have soil pressure coming against a box that actually deflects the box in, it doesn't enable you then to drag it ahead, because you can't pull ground and push it back. So one of the main issues that can be concerned about when picking a box out to use is what kind of pressure is going to be against that box, and how much deflection would you have with that trench box. That's one of the reasons that Kendall Industries decided in the Titan series to do a 5-inch wall versus the 4-inch wall, because now the flanges are a little further apart, and it doesn't deflect as easily as a 4-inch wall. Yes. Some other issues with dragging and driving a drag box is one of the connected to the vertical cutting member that Kendall Industries on the Titan series brings the outside skin out slightly past the end tube and puts a thick vertical weld in. So as you drag the box ahead, it has a tendency to cut the soil. So really you need to move a box ahead, the soil needs to be cut at least the width of the box, a little bit wider. You really can't push the ground back and up. Another issue is with a tapered knife edge. Two reasons. A tapered knife edge enables you to drive the box down to the ground, and it cuts the soil as you drive it down. The next issue is that it gives you more room in the pipe zone, so when you drag the box ahead, it leaves a less of a void behind. So what Kendall Industries does is we make a high tapered bottom. We make a 1.5 foot tapered bottom versus the 8-inch on our competitors. So it doesn't leave as much as a void when you drag the box ahead, so that fill around the pipe doesn't slough down and cause you deflection in the pipe you just laid. Also, we keep a clean knife edge. We don't put no holes in the knife edge for a rigging point, because when you drag the box ahead, it'll pull the fill around the material, slightly drag it, and if your pipe you just laid is close to the edge of the box, then that box could catch that fill material around the bedding material around your pipe, drag that, and that in turn could drag and pull your pipe apart and leave you a leak behind. Okay, that concludes the discussion on how do you use, in the simplistic terms, how do you use a drag box. Thank you.